another way to identify a quadratic relationship, or a graph that makes a parabola, is by looking at a table of values and determining the first and second differences of that table of values. So for example, on the left-hand side, we have a table of values that gives us both x and y coordinates. And so what we need to do to figure out whether or not this equation is linear or quadratic is actually determine the first and second differences. So recall from last year and from grade 9 that a linear relationship is literally a straight line. Okay, and so if you have an xy coordinate system, a linear relationship is just going to be a straight line. However, a quadratic relationship, if you have an xy coordinate system, a quadratic relationship will be in the shape of a parabola, or of a kind of a U shape. Okay? So in order to figure out the first differences, what we need to do is actually find the differences in consecutive y values. Okay? And so to do that, what I like to do is I always like to start from the bottom of a data table, or of a table of values, and then move up. So for example, if I want to figure out the difference, and difference means subtraction, okay, so the difference in price, or the difference in height, that's a subtraction question. So if we're looking at the differences between two consecutive y values, then what I'm going to do is I'm going to take two consecutive y values and I'm going to subtract them. The first y value is going to be the lowest one. So in this case, -3, or rather the one that's further down on the table of values. So -3 minus -5, okay, and that's going to equal +2, because negative minus two negatives is going to end up being a positive. So this ends up being +2. Okay, so these two negatives together actually become a positive. Then I'm going to do that same process again. This time I'm going to do -5 minus -7. So -5 minus -7 is actually equal to +2. -7 minus -9 is also equal to +2. And finally, -9 minus -11 is equal to +2. Now, one thing that we'll notice right off the bat is that the first differences, and the differences here is the resulting value of subtracting consecutive y values, the first differences are all the same. So they all happen to be -2. Okay? And so because the first differences are the same, so I can write, we don't even need to calculate second differences because the first differences are the same, and that tells us what type of relationship it is. So first diffs are the same. Therefore, it is a linear relationship. Okay? So anytime that the first differences are the same, it is going to be a linear relationship. Okay? So the conclusions that it's a linear relationship. So if I was to actually graph this on an xy coordinate system, what I would end up having is something that looks like that. Okay, it's going to be going up. And again, when you did this in grade 9 and you did it in grade 10, you also learned that the differences in a linear relationship is the same as the slope. Okay, so in this case, the first differences are +2. That means that this particular line has a slope of +2. However, you can also have a situation where your first differences are not the same. So in this particular, in example 2 here, we also have a table of values. And what we see in this table of values is that when we calculate the first differences, they're not likely to be the same. So if I go and I subtract consecutive y values, for example, 7 minus 6, well, that equals +1. If I then continue on and I do 6 minus 3, that equals positive 3. And if I do 3 minus negative 2, that equals positive 5. And negative 2 minus negative 9 equals positive 7. Let me try that again. Equals positive 7. So my first differences are not the same. And because the first differences are not the same, I know automatically that it cannot be a linear relationship. So let's take a look then and prove that it is in fact a quadratic relationship. And you will have to be able to prove that it is a quadratic using first and second differences. So being able to do this subtraction piece. So what we'll do now is instead of subtracting the differences in the y values, we're actually going to subtract the first differences. So in this case, these are our first differences here. And so this is what we're going to be subtracting next. So if I want to check out the second differences, I'm going to again work from the bottom to the top, and I'm going to subtract or find the difference between two consecutive first differences. So in this case, 1 minus 3 equals negative 2. 3 minus 5 equals negative 2. 5 minus 7 equals negative 2. Okay, and there's a pattern there. And that pattern is that the second differences, the second time that I go through and I find the differences, they happen to be the same. Okay? And so in this instance, my second differences are the same. And because my second differences are the same, that means that this is actually a quadratic relationship. Therefore, it is a quadratic relationship. So again, anytime that you have first differences that are the same in a table of values, it's a linear relationship. If you have second differences that are the same in a table of values, it is a quadratic relationship.